Our brain is the main reason that we're able to move. If you want a body part to move, an impulse will be sent from the brain and the CNS down towards the muscle to cause a contraction. This is an action potential which could travel down the spinal cord and until it reaches a motor neuron. On this motor neuron, saltatory conduction will take place. The stimulus would have to jump over the myelinated sheath of the motor neuron. This is because the myelin sheath is made of cells where depolarization does not occur. Depolarization is a change within the cell. It then goes along the axon at a faster rate, which means the muscle would move faster as the impulse is faster as well. After saltatory conduction, the impulse will reach the neuromuscular junction. This is a gap between the motor neuron and the muscles. In order for an impulse to travel through the neuromuscular junction, it will have to release chemicals called neurotransmitters. An example of this is ACH. This will travel down the vesicle until it will reach the presynaptic membrane. This will travel through the gap and go towards the postsynaptic membrane. When it has reached the postsynaptic membrane, there will be the sliding filament through the sarcomere in the muscles where the contraction will be happening. A motor unit is made up of motor neurons. When doing exercise, motor units vary depending on the duration and intensity of the exercise. This is so the motor units will provide a different type of contraction. There are three types of motor units: the slow oxidative fibres, fast oxidative glycolytic fibres, and the fast glycolytic fibres. There needs to be tension in the muscles, therefore these motor units need to be recruited. More motor units to create the tension. Slow oxidative fibres will be recruited if the muscles are not working that hard and can last a long time. So, as an example of this would be a marathon. As these are fatigue resistant, due to having the highest amount of mitochondria. Fast oxidative glycolytic would be used in runs like 800 meters, and fast glycolytic would be recruited in runs such as sprinting. The faster the motor unit, the faster the tension is built. However, the slow oxidative fibres will cause the tension to last longer than fast glycolytic and fast glycolytic oxidative fibres. If there are multiple action potentials, then the tension will keep rising until it plateaus. But you can still see the effect of the action potential on the tension. The number of motor units recruited depends on how large the resistance is. The higher the resistance, the more motor units are needed, as the muscle needs to overcome the force that the muscle is trying to fight. Typically, smaller muscles require fewer motor units, whereas large muscles require more motor units. For example, the quadricep would need loads. The size of the motor units are determined by the number of muscle cells inside them. So if a motor unit has a more exert, which is a larger force, slow oxidative fibres are first called up, then the FOG, and then the FG. As the FG have the highest force and so have the least, the FG is the higher force and the slow oxidative fibres have the least force. So if a higher force is needed, only the slow oxidative fibres and the FOG fibres would be called up. If that's not enough, then the fast glycolytic fibres have to be called up at the end. In order to prevent tear and too much tension in the body has muscle spindle apparatus and Golgi tendon organs. Firstly, the muscle spindle apparatus are in the belly of the skeletal muscles, and they detect stretch and the velocity of the muscles. This is because they have extra fusal fibres, which is acting on myosin. This means that a contraction can occur. These are also intrafusal fibres in between these extra fusal fibres, and these are the main parts that detect the stretch. This would send an impulse to the brain, also going through the spine. After the brain has received the information, it will send back an impulse through an alpha motor neuron, through the neuromuscular junction, and into the muscle, causing a contraction. When doing a weight lift, an eccentric exercise can cause the muscles to stretch, therefore this contraction will shorten the muscle so it doesn't tear. This is a stretch for reflex in your muscles, where it can be tested on your leg by lightly hitting your knee tendon with a small hammer. When this happens, your quadriceps and hamstring will stretch and the impulse will be sent to the brain, and the brain responds, causing the muscle to contract in the quadriceps and the hamstring, causing the knee to jerk a bit. The muscle spindle is also involved with the stretch-shorten cycle. This cycle uses eccentric contraction and the muscles are pressed. The cycle is where someone can jump higher than they normally can as the force exerted is a lot larger due to the pressed muscle. There's also another exercise which uses maximum force in your muscles, the plyometric exercise. This exercise a quick, fast jumping up and down when the muscles will stretch quickly, which will result in the muscle contracting quicker as well, therefore more force will be exerted as the muscle spindle apparatus will stretch. The tendon connects the bone to the muscle, and inside the tendon is the Golgi tendon organs. These detect tension in the tendons. When there is too much tension, the nerve will be sent to the brain, and the alpha motor neuron will send an impulse to the muscles, and the muscles will relax. The muscle will relax. Our class carried out a Wingate test, and it's normal for the student to produce the highest power early on, then drop off. The extent depends on the amount of oxidative fibres which are present. For example, some people are born with more fast oxidative fibres and others born with more slow oxidative fibres. These are used when an impulse is detected. Once a stimulus has been detected, it's sent to the brain, which is then sent down to a motor neuron, and then at the very start, slightly the slow oxidative fibres are being used. The student hasn't reached his maximum power. The student has reached his maximum power after a couple of seconds, and it was around 640 watts, which I mentioned before is a maximum. Once a student has reached this, they begin to drop off slowly, or drop off very fast. This shows that the fast glycolytic fibres are taken over. The student is working anaerobically. The neuromuscular system is vital to allow contractions to occur. Different motor units are active during different contractions depending on parts of a football match and the actions which need to be performed by a player. Football consists of constant running as it is a free-flowing sport which lasts 90 minutes. Therefore, contractions are always happening. These contractions are needed for the player to move. Therefore, the brain is sending messages from the brain to the muscles via the central nervous system, to allow them to contract. Slow oxidative fibres will be recruited when the players are running, jogging and walking throughout the game, as these aren't powerful contractions because these motor units don't fatigue. When a player is shooting the ball, it's likely fast glycolytic oxidative fibres are recruited because these are used for quick, powerful contractions, which is completely different to slow oxidative fibres. When the ball is kicked, the hamstring will be stretched, so when this happens, an impulse is sent to the brain to relax the hamstring.